Hello, we're going to talk about rounding numbers. So let's do a review of basic rounding. So anytime you round off a number, you need to understand that if the digit after the one being rounded off is less than 5, then we are going to round down. If the digit after the one being rounded off is more than 5, then we are going to round up. All right, so let's do some quick examples. Number 1, it says round 438 to the nearest 10. So I would identify the tens place. So if I'm trying to round 438 to the nearest 10, I'm rounding to where that 3 is. So I look at that 8. That 8 is bigger than 5, which means I need to round that 3 up, which will end up making me have 440. If we look at number 2, it says round 724 to the nearest 100. So if I write down 724 and I identify my hundreds place, I want to round to where the 7 is. So that means I need to look at the 2. So if I round it, it's going to be just 700 because the 2 was telling me to round down to the nearest number, which is 700. Number 3, round 2050 to the nearest 100. So if I write 2050 and I'm underline my hundreds place, the 5 after that 0 is going to tell me to round that 0 up to a 1. So that is going to round to 2100. If we look at number 4, it says Jason made $64,791 in 2020. Round his earnings to the nearest 1,000. So if I write down 64,791 and I want to round it to the nearest 1,000, I round to where that 4 is. And that 7 is telling me to round that 4 up to a 5, so we can round that to 65,000. Number 6, round 6.17 to 1 decimal place. So if we say round to 1 decimal place, that means we only want to see one number after the decimal, which means we need to round to where that 1 is. And the 7 is going to make that 1 a 2. So we should have 6.2. And last but not least, for number 6, it says round 9.2748. We're going to round that to the nearest 2 places. So that's 2 places after the decimal where that 7 is. So the 4 is telling me to round down, which means I'm just going to have 9.27. That's 2 decimal places. All right, so let's talk about significant figures. So this is going to be something that is brand new to you, significant figures. So anytime you have significant figures, you need to understand that the very first significant figure of a number that you are going to see is going to be the first leftmost number that is not 0. Okay, so it's non-zero. So every digit to the right of the first significant figure is going to be significant as well. Okay. So basically, you have to identify your first significant figure before you can identify any other significant figure. So once we identify our significant figure, where we want to round to, then we use our regular rounding properties, which states that if the digit is less than 5, we are going to round down. If the digit is more than 5, we are going to round up. So let's look at some examples in action. So it says round 5.384 to 2 significant figures. So when I write down 5.384, my first significant figure is the number that I first see that is not 0. So 5 is my first significant figure. I want to round to the second significant figure, which is going to be that 3. So when I round it, that is going to end up giving me a 5.4. That is my answer in 2 sig fig. That's short for significant figures. Number 8, it says round 0.0672 to 2 significant figures. So if I want to do that, then I'm going to rewrite 0.0672. The first significant figure is the first number that you see that is not 0. So 6 is my first significant figure. And if I want to round to the second significant figure, I need to round to where that 7 is. Now, what you need to understand is that even though the zeros in front are not significant, you still have to write them, okay? Because your place value should stay the same. So we're going to have 0.067. That is 2 significant figures. If we look at number 9, it says that we need to round 749 to 1 significant figure. So the first number that's not 0 that I see is 700. And when I round it to 1 significant figure, that is going to be 700 because the 4 is telling me to keep the 7 and just round down. Last but not least, with significant figures, let's look at number 10. So example number 10 says round 90.851 to 3 significant figures, or 3 sig fig. So we write down 90.851. The first significant number that we have is 9. So the 0 that is after that 9 is also significant. And then the third significant figure is going to be that 8. So that 5 is telling me to round that 8 up. So that's going to be 90.9 in 3 sig fig. All right, 90.9 in 3 significant figures. Okay, so let's look at when we do approximations. So what you need to understand is that anytime we want to do an approximation, a quick way of estimating a calculation is to perform a 1-figure approximation, okay? A 1-figure approximation. And when we do this, you need to understand some key things. All right, the first thing that you want to do is you want to leave the single digits as they are. You're not going to mess with the single digits. Then what you're going to do is you're going to round all of your other numbers to 1 significant figure, and then you can perform the calculation. So let's do 3 quick examples. So if we were to do number 11, it says estimate 781 times 63. So we have to write it as 1 figure or 1 sig fig. So 781 rounds to 800 in 1 sig fig times 63, which rounds to 60 in 1 sig fig. And if we do, of course, 800 times 60, we would get 48,000. That is my approximation. Number 12, it says estimate 65,197 times 813. So what we're going to do is we're going to round to 1 significant figure. So that 65,197 is going to round to approximately 70,000. And then we're going to multiply it by 800. So when we have 70,000 times 800, we will end up with 56 million. Okay, 56 million. And because I don't have enough space to write all those zeros, I'm just going to put MIL for million. Okay. All right, so let's look at number 13. So number 13, we have 9.61 times 0.6 0.327. So 9.61 rounds to 10. And then we want to multiply it by 0.3 because that is the decimal rounded to one significant figure. So of course, if we do 10 times 0.3, you're going to end up getting 3. Now, to talk about the errors in measurement, you need to make sure you understand is that a measurement is accurate only to plus or minus 1/2 of the smallest division on the scale, aka the smallest place value. So let's look at some examples. So number 14, it says, Genesis uses a ruler to measure the length L of her foot. She records the length as 96.5 centimeters. Find the range of values in which the length may lie. So remember, you have to look at your smallest place value. So if I look here, the smallest place value is the 10th position. That's with a TH, 10th. Okay? So if we look at the smallest place value, and I'm going to abbreviate it, smallest PV, I'm going to put that as 0.1 because that stands for 1/10. Okay? Now, as far as the accuracy of measurement or the error in the measurement that you can have, we can have the accuracy or the error is going to be plus or minus 1/2 of the smallest division. So we're going to have plus or minus, we're going to do 0.1 divided by 2, since it's 1/2 of that amount, which means that we can either go below or above by 0.05. Okay, so because we can do that, it's easy for us to say our answer. So we already know that the length currently, as she has learned or she has measured, is 96.5 centimeters. So I can go below or subtract 0.05 centimeters, or I can add 0.05 centimeters. So it looks as if my lower bound is going to be 96.45, and my upper bound is going to be 96.55. So this is the range of values that that the length of her foot may lie in. All right, so let's look at number 15. It says Kamari wants to put a fence around his 16 by 9.5 foot rectangular yard. Find the boundary values for its perimeter. So we should understand that perimeter means we're going to add all the sides. So what I want to do is I want to figure out the lower and the upper bound of my length and my width. So we have to make sure that we pay attention to the place values. So if we look at 16, okay, the smallest place value here is going to be the ones position. Okay, and our error is going to be plus or minus 1/2 of 1. So that means that we are going to have 1 divided by 2, which means that we're going to have plus or minus 0.5. That's for the 16. If we look at the 9.5, the smallest PV or place value that we see here is going to be the 10th position. So that's 0.1. So when we want to find our error, we're going to have plus or minus 0.1 divided by 2, which is equal to plus or minus 0.05. All right, so I'm going to calculate the perimeter with the lower bound, and then I'm going to calculate the perimeter with the upper bound. So if I look at my lower bound, if I find out my lower bound of 16, if I do 16 subtract 0.5, my lower bound will be 15.5. if I look at the 9.5 and I subtract my lower bound, it's going to be minus 0.05. So 9.45 is my lower bound of my measurement of 9.5 feet. So all I have to do, remember, perimeter is 2 times the length plus 2 times the width. So for my lower bound numbers, I'm going to have 2 times 15.5 plus 2 times 9.45. And that's going to end up giving me 49.9 for my perimeter on the lower end. Okay, so that's going to be 49.9 for my perimeter. And I'm going to put P for perimeter here. Now we have to do the same thing for the upper bound. So I'm going to take 9.5 and I'm going to add 0.05 to it. And I have the upper bound of 9.55, and then I'm going to take 16 and I'm going to add 0.5 to it, which means I'm gonna have 16 and a half as my upper bound. So then I'm gonna do my perimeter formula. So I'm gonna have 2 times 16.5 plus 2 times 9.55. And that gives me that my upper bound for my perimeter is going to be 52.1. All right, so for number 16, it says a cement block is measured as 43.01 times 29 centimeters. What are the boundary values for its actual area? So remember, when we are talking about area, we are referring to length times width, okay? So yes, we are talking about a block, but we are not talking about volume. I am talking about if I were to lay them out on the floor, how much space will be covered, okay? So let's get into it. So if we take the 43.01, we need to look at the smallest place value. So the smallest place value, and I'm going to abbreviate this, the smallest place value is going to be the tenths position, or the hundredths, the hundredths position. So I'm going to put 100 there. Now, in order to calculate the area, or the error, you will have to take plus or minus your lowest place value and divide it by 2, which means that my error is going to actually be plus or minus 0.005. All right. So now we need to look at the 29. So if I look at 29 here, the smallest place value is going to be the ones position, which means that my error will be equal to plus or minus 1 divided by 2, which is equal to plus or minus 0.5. All right, so let's look at the lower bound area. So if we take 43.01 and we subtract 0.005, we will end up with 43.005. If we found the lower bound of the 29, we would have 29 subtract 0.5, and we get 28.5. So if I want to find the lower bound area, I would just multiply 43.005 times 28.5. And I will end up getting 1,225.6425. That's my lower bound for my area. So I need to do the same thing for the upper bound. So to find my upper bound of 43.01, I'm going to add 0.005 to it, and I get 43.015. And then in order for me to find my upper bound of my 29, I am going to add 0.5 to it, and I get 29.5. So now I can find the area by multiplying those two upper bounds. And I will end up getting 1,268.9425. That is the upper and the lower bound, or the range of my area, the lowest and the highest that my area will be. So if you have any questions, please reach out to me. I will be glad to help, and you all have a great day.